pick up right in the middle here because I didn't turn it on right away. We were saying direct information leads directly to either saying a segment is congruent to a segment or an angle is congruent to an angle. Those are the kinds of facts we need. To say side, 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 or side, angle, or angle, or angle, angle, side, to say one of those four, we need to be given information about sides, which are segments, or angles. Okay? And so I call those direct information. These kinds of statements are not saying, they're not saying that two sides are equal, they're not saying two angles are equal. They're saying something else. Those types, these three here that I boxed in, I consider that indirect information. It's really important because it leads to one of the things we want, but it's not saying it exactly. Where this one here is a direct fact. It's saying this side is equal to this side. Okay? So we have to understand the difference between those two. You don't necessarily have to use my terminology and call it direct or indirect, but that's how I'm going to refer to it for the next 3 weeks. So probably you should just get used to that. But you do have to identify that it's not saying exactly what we need yet. So let's look at these two because they are saying basically the same thing. They're saying that this segment is perpendicular to this one, and this segment is perpendicular to this one. And so we have to ask, what does that mean that they're perpendicular? Why would they give that to us? And so who has a thought on what it means to be perpendicular? What's that? They're never going to be parallel. I agree with that. Well, actually, segment DB and segment CM are parallel because of the theorem that says if two segments in a plane are perpendicular to the same segment, they're parallel to each other. But what does it mean to be perpendicular? What's special about it? Normally, when you see that little box in the corner, what do you think of? 90-degree angle. Okay? Normally you see this little box here, and you don't think perpendicular, you think 90 degrees. So that's close. What we're going to say is that angle DBM and angle CMA are right angles. Okay? We're going to say they're right angles. The definition of perpendicular means that the two segments or lines or rays intersect to form right angles. That's what the definition says. So how did I know that these two are right angles? By the definition of perpendicular. Now, most of us want to jump straight to saying they're right angles. But the fact of the matter is, or 90 degrees. But the fact of the matter is, perpendicular means that they're right angles. Now, again, the reason I chose to do this one for you, not ask you guys to do it in your group, is because there's some little tricky things that seem obvious that really should be written down. That, since you have very limited experience on this right now, it would be difficult for you to get. But the next step, we're going to say that these two right angles are congruent. These two right angles are congruent. So we're going to say that angle DBM, that's right. Angle DBM and angle CMA are right angles. Here's DBM, so this angle here, and angle CMA, this angle here, are right angles. And I know most of you are going to look at that and say, well, couldn't have I said that right away? Well, yes and no. I agree with you that we right away they're right angles, but it was because of the definition perpendicular. And then it's because of a theorem given to you on page 99, and all it says is right angles are congruent. Right angles are congruent. That's all it says. There's no name to it. There's nothing special about it. It's just pointing out the fact that right angles are congruent. Okay? Now this is one of those direct facts now, isn't it? It's saying two angles are congruent. This one said two sides are congruent. And so we have how many facts now in this triangle? Louder? Two. We have a side and an angle congruent to this side and this angle in this triangle. So we're almost there. And so if we go back to the given and say, why did they tell me this? Why did they tell me M is the midpoint of segment AB? If M, this point right here, is the midpoint of this segment, what does that mean? It's in the middle. More precisely, it's what? Exactly in the middle, cutting it into two equal pieces, right? And so if this cuts into two equal pieces, then what statement can I say about this now? Segment AM is congruent to segment MB. Segment AM is congruent to segment MB. Anybody tell me why we knew that? Nice. Definition of midpoint. They told us it was the midpoint, and because I understand the definition, I can make this next statement. And so that's the definition of midpoint. Now when I go back to this picture, how many facts do I have in this bottom triangle now?
3.
And how many in the top one?
3.
Are they corresponding?
Yep.
Yeah, and so what rule tells me these triangles are congruent now? Side, angle, side. We have one mark, an angle in between, and then two marks, right? In both pictures. So now we're ready to say triangle CMA is congruent to triangle DBM by side, angle, side. When they give you perpendicular, it takes two additional steps to get to the statement you really want to make. You have to say that that makes them right angles, and then you have to say the right angles are congruent. You can't skip right to saying that and assuming that you've already written it. You have to make those other two steps. Now, we don't do this too often, but when one like this arises, you have to take these two steps to get from perpendicular to here. Okay? Anybody not finished with this proof yet? Okay, if we go backwards, this one's a little easier. The given says that segment JG is congruent to segment MG, and it says GK, segment GK, sorry, bisects angle JGM. Try that one in your groups. I'll wander around. I'm going to orient this board again. Okay, I know we're not all done, but again, we're just getting started in this whole process, and I don't want to spend 15 minutes of dead air time not accomplishing as much as we could. So let's go through it together. Segment JG congruent to segment MG, and segment GK bisects angle JGM, and that was all given. And I like Hunter's comment. He says, we all got the given, but we don't know what to do next. But that's the key I'm getting at, is every little step you get is closer to getting it. And when I'm grading it, every step you get is going to be worth something. Okay, so even if it's only the given, that's a place to get started. And so Hunter's group also recognized that this is direct information and this is indirect information. And so my comment, next question is, if this is indirect information, then what does it mean? And we have to ask, why did they give that to me? Because what it means is probably what I'm going to write right here. And so segment GK, that's this segment, bisects angle JGM, this angle here. And so what does it mean if it bisects that angle? What's that? Cuts it into half. Cuts it into, even more precisely, two equal halves. Okay? Two equal halves. And so what can I say then about this? If this cut this angle into two equal halves, then what's the next statement? The midpoints are of segments, not of angles. So if it cut this angle into two equal halves, then doesn't that mean this angle and this angle are equal? Right? Those are the two angles it created, right? By cutting it in half. If I took that line out of there, I wonder if I can. Yeah. If I took that out of there, I'd just have this one big angle, wouldn't I? Okay, but by putting that bisector back in the middle, I've cut that big angle into two equal angles. And so my next statement down here is going to say that angle what?
Does it matter what order your statements are?
Makes no difference on the first one. The second one needs to match in the right order. So the first one is what? JGK. I shouldn't say it doesn't matter in the first one. G has to be the middle letter, no matter how you label it. Okay?
No, like, does it matter what order, like, if you did it?
Oh, which step? Oh, no. No. No, if you recognize something else first, that's okay. As long as the last step is the one with the triangles. That's got to come after these other facts. So angle JGK is congruent to angle what? MGK. And why is that? There you go. Definition of bisects. Okay? And so now I have, I'm going to put 2 marks on here. I have 2 facts now in each triangle, right? I have the segments J, G, and MG, and I have the angles J, GK, and MGK. And so I need a third fact, and if I go back to the given, this was direct, so that's used up. This was indirect, but I used it to get this statement, right? And I would ask, does it say anything else? But the reality is it doesn't. It only gives us the fact that it bisects this big angle, cut these two, and created those 2 equal angles. And so that's done. And so when everything's done that they gave you, you have to go back to the picture. And something in the picture is really important, Amber. What's that? They share segment GK. That's correct. And so if they both share the same line segment, and it's not like they only share part of it, they share the entire segment, then what statement can I say? Louder? Okay, but what do I say here? What's my statement? Segment GK is congruent to segment, actually it's GK again in this case. If we go over here and look, if we go G to K, then over here it's also G to K. So it's the same order this time. On Thursday when we did it, they were reversed. The pictures were reversed from one to the other. But in this case they're not. And you can always check that out in this statement right here. When they put them in order for you, you can use that order to help you arrange your orders. And again, I'm not trying to indicate I'm really going to hammer you for that kind of stuff. I wouldn't even mark that wrong if you had those switched around. But we need to start identifying the proper order to write things, okay? Because at some point there will be consequences for putting them in the wrong order, because you'll be saying not what you think you're saying, okay? And you already told me this was reflexive property. And then remember, reflexive, if you abbreviate reflexive, it could look like reflection or reflective, and then we have a problem. So you just need to write reflexive out. And if we mark it in our picture, put a couple marks there just saying it's equal to itself. The reason I do that is because now I can look at this bottom triangle and say I have this side, then I have the angle, then I have this next side, the angles between them. So what allows me to say that these two triangles are congruent? Side, angle, side. So we say triangle JGK congruent to triangle MGK because of side, angle, side. Okay? Questions on that one? Okay, I'm going to jump to lesson 4.3 now, the bottom of page 199. There's 4 proofs there. At least there's pictures and setups for 4 proofs. They probably didn't actually ask that, but we're going to. We're going to treat them like proofs in practice. And so I'm going to pause this while I copy down number 31. Yep, 31. So number 31 looks something like this. And in this picture, there's some extra information. Okay? And when I first looked at it, I thought we were going to be saying something different than what we are going to be saying because I didn't look at the triangles yet that they were asking for. And so if we highlight these 2 triangles, we're talking about this triangle and this triangle. Okay? So the question is, does this line have anything to do with those triangles? No. And so probably for most of us, pulling those 2 lines out of the way makes it way less confusing to look at what's important. Okay? And so if we look at this information, we mark the given. I always think you should mark the given in your picture. Angle N, that's this angle, is congruent. Angle N is congruent to angle P. So we mark that. Segment MO is congruent to segment QO. That's that. Okay. Might be easier to see if I would get rid of these also. And so if we write those given down, step 1, angle N congruent to angle P, segment MO congruent to segment QO. It's all given. What kind of given is that? It's direct, isn't it? It directly says 2 segments are congruent or 2 angles are congruent. It's not some hidden message that we have to decipher. It's just come right out and saying what we want to hear. And so now we need to find a third fact, right? Either another pair of angles are congruent or another pair of segments are congruent. And there's nothing else in the given, is there? That's all there was, those 2 direct statements. So we go back to the picture. What's that? What about O? Oh. Not necessarily. MO and PO, they didn't tell us that O was the midpoint. And they didn't tell me that QO bisected MP or anything like that. Right? We have to be told something like that to make that assumption. Okay? Jackson?
MOP is clear to QOP because of vertical angle.
Yes and no. You're not labeling your angles correctly. You want to try it again? Angle MO.
Or N.
Yeah. Angle MON.
And then QOP.
And angle QOP. He's saying this angle and this angle are vertical angles. Okay? And you are correct on that. So that means then that this angle is equal to the angle below it, vertical angle. So the next statement is going to be that angle MON is congruent to angle QOP because of vertical angles theorem. So, how many facts do I have now? 3. And what are they?
Angle side.
Nice. They're angle, side. And so we're ready to say, in just 3 steps here, that triangle, MON, is congruent to triangle QOP because of angle, side. That's exactly correct. So, I don't think I can drag all this over. No. Let me read through it to make sure you can read what it's saying. That bottom one you haven't been given yet either, so at this point, we'll just write this down, and then when we get to the CPC-TC, we'll pull this page back out and add it. It's triangle congruent statements, and these are the 5 you will learn. Again, we haven't learned this one yet. focusing right here, but we will. Okay? So we have side, 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 angle, side, angle, side, angle, 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 side. And then off to the right side here, in red it says, these are the only way to prove triangles are congruent, and you can't use them for anything else. What happens on a test is people start to scramble for ideas what to write down, and they start throwing SAS, SSS, ASA, and AAS, and HL in for anything. And I'm just telling you the only times we can use them is when the statement says a triangle is congruent to a triangle. You can't use it for segments congruent to segments, or angles congruent to angles, or anything else. The only time those green 5 rules can be used is when you're saying a triangle congruent to a triangle. And then, also on every one of those 5, it takes 3 facts to prove that those triangles are congruent. It takes 3 facts to use them. Even in HL, where it says hypotenuse leg, one of the 3 facts is that it must be a right triangle. And so that's what I'm saying here in blue. One of the 3 facts is it must be a right triangle. So even where there's only 2 letters, H and L, H stands for hypotenuse, L stands for leg, we're talking about a right triangle. And so we have to identify one of our facts in our proof has to be the fact that it's a right triangle. Okay? Alright. Pause while you finish copying. So on number 34, I want you to try this in your group. Very similar to some we've been working on. Probably be the last one we do today. Okay, so wander around while you work on that. All right, just a couple minutes here to finish up. So the first thing we did was wrote what? The given down. Does anybody feel that you would rather write the given as you need it and as you use it, or do you like just putting the given down like I do? Or is it you just do that because that's what I do? You can think for yourself and make that decision. See, the book would write this down, write given, and then they'd tell what it meant on the next step. Okay, and then they would write the next one down as the given, and then go from there. They would have an extra line at least. The way I do this, I'm just putting all my given together, and I write given once, and I have one less step. I'm not doing too much less writing, I'm just, okay? So the question is, what does this mean? What's that mean, Dalton? There I boxed in here. Segment DH bisects angle BDF. So if this segment bisects this angle, what does that mean? Why is that important to us?
Because those 2 angles equal that one.
So, can you name one of the angles so I know what you're talking about?
BDH.
So you're saying angle BDH is equal to
Angle FDH.
and I said equal, but I meant to say congruent. Angle FDH. That's well said. And why is that? How did I know that they were equal?
Because angle 1 and 2 are equal.
No. No. These 2 being equal have nothing to do with these 2 being equal. But what did they just tell me that led me to that statement?
That bisect.
It bisects. So what do I write here? Definition of bisects. They just told me that it bisected that angle. So that tells me it cuts into two equal angles. And then we're almost out of time, so just real quickly, DH is the same in both, right? So we're gonna say segment DH, congruent segment DH because of reflexive. And then what rule says my triangles are congruent? Angle, side, angle, because in this case my side is between my two angles, isn't it? Okay, good.